Greetings, dear instructor. In this presentation, I'll be talking about my capstone project, implementing a network security monitoring system using open source tools for the award of a degree in Masters of Science in Information Technology at the University of the People. This project looks at how we use open source software to detect, analyze, and display intrusions that this system will be detecting in networks, because small and medium-sized enterprises are always faced with intrusions, since as they carry large amounts of data through any network system. For the background, I've already talked about it. These intrusions can be as a result of unauthorized access, network port scanning attacks, and distributed denial of service attacks. Denial of service is just when network resources are made unavailable to intended users. So these attacks might prevent users to get available resources that they actually need. Now, many small and medium-sized enterprises lack affordable and effective solutions for real-time network monitoring, intrusion detection, and centralized security analysis. Now, the purpose, objective, and scope of this project is to develop a cost-effective network security monitoring system solution using open source technologies. This will be to monitor network traffic in real time, detect suspicious activities, and process centralized security logs, and also visualize security events using dashboards. The program we'll be using here, or the system or the tool we'll be using to visualize security events, will be Kibana. The scope and the tools we are going to use are as follows. You have a Wireshark. Wireshark will be the packet capture of data. You have a node which will detect the intrusions that Wireshark will detect, that Wireshark will capture rather, and then log dash will be there to produce a dashboard for log processing management, and Elasticsearch will just be there to store the data and index, while Kibana will just be there to display out. The system architecture diagram look like this. From just what I've explained, there will be security access control, and the user interface will be provided by Kibana, data storage and indexing by Elasticsearch, log management, you have a Logstash, and then intrusion detection by Snort, packet capture by Wireshark, network traffic source by a simulated visual machine that I already had to install here. Now, I'll be looking at the system components and the technology that has been used. It's just a repetition of what I've already said. These are the system components. We have a Wireshark, we have Snort for intrusion detection, Logstash, Elasticsearch, Kibana, and GitHub is for version control. There's other developers who are there to build this particular project that we are going to look at here will be call lock implementation. Snort intrusion detection rule was input like this in our virtual machine using our Linux OS. And the main function is to monitor ICMP attacks or packets that generate alerts and detect ping activity, while this is the snort rule configuration. Now, after that, you have the input output example. Now, this ping and this IP here is the IP that is being accessed by the network or by the system. It accesses this IP on the network system, and it will produce this, which shows that Snort has successfully detected the malicious or suspicious ICMP activity. Now, for my system integration and intermodule communication for log stash configuration, therefore log management, you will see that there is Logstash, Elasticsearch, and Kibana for that. This is the Logstash output, which shows that an IP of such address 192.168.1.110.10 has mapped a destination address with IP 192.168.1.28.20 to show that an alert has been pinged, or an alert ICMP has been pinged. Or now, for my system integration, you would notice that you have a Kibana dashboard feature, and this will be the display of whatsoever that will be displayed. To enlarge, I'll just do this, and it is directly showing that the total alerts that were detected 152, and here will be Logstash analysis showing everything that the network system picked on the 11th of April of 2026. Now, the next thing that we look at will be the evaluation of the results that were detected in the network from the ICMP ping results. Now, these metrics, you have the results showing a detection accuracy of 92% and an alert latency of 1.8 seconds. And the log processing rate was by Logstash shows that you have 150 logins per minute and an indexing rate of 98%. This index coming from research, so Kibana had to display. Here you have a bar chart showing the performance metrics from the network security monitoring system. Now, from the result, it shows that the network monitoring system has provided and detected intrusions from the log management and with a timely security monitoring, supporting the project's objective of cybersecurity visibility for small and medium-sized enterprises. And here you have a research from that has been cited in the 7th edition. Here you have the dashboard results and the finding, the Kibana dashboard results and the findings. You have Kibana results of 152 alerts as shown here, you would see, and ICM scan alerts of 55 and port scans of 42 and index logs of 1,500 plus. Here you have an alert frequency monitoring graph, which successfully reads that the activity increased significantly from this period in the time period of 10 minutes. Yes, indicating that the simulated ICMP and port scanning attack was successful, and then it has the highest value of 152 alerts at 5 minutes from the time that the alert was detected. That's at 2:52, 2:20, and then the alert was run at 2:15, reflecting the highest level of suspicious network activity. Now, this graph here, you see that the graph slopes upwards and then slopes downwards, and then it tells you that it confirms that the integration of Snort, Logstash, Elasticsearch, and Kibana for intrusion data and storage index. I was saying, the results from this graph, sorry for the interruption, time for my screen recorder elapsed. So from the graph, it shows that the peak value of 152, 52 alerts were detected within a period of 5 minutes from when this was detected until when it ended, reflecting the highest level of suspicious network activity. The graph confirms that the integration of Logstash, Snort, Elasticsearch, and Kibana for log management, intrusion data storage, additionally with the user interface, was successful in real-time monitoring and visualization of the network security. Now, what we have here are the challenges and the solutions. It's not ELK integration issues, corrected pipeline configuration. This really affected my project a lot. And then we had a false positive, which refined IDS rules. You have log passing errors, modified log stash filters and processing delays, optimized elastic setting. And also the challenges that I face in the project was that my version of virtual machine, as I'm going to show, advanced because I downloaded Ubuntu 26.04 LTS. That's an upgraded version. I couldn't find 4 or the 24 version for Ubuntu. It couldn't just be found on the internet. So I had to download the one that was found for my Windows operating system. At some point, some codes was not Logstash, Elasticsearch, and Kibana were not successful because of that, because of doing some strings or lines of code as the system is being upgraded. Now, some contributions and implications are as affordable CM solutions. You have improved network visibility, centralized monitoring, modular architecture, open source implementation. Now, when I talk about affordable CM solutions, improve network visibility, I'm simply talking about the fact that small and medium-sized enterprises now will have an affordable, because this system is cheap to detect malicious attacks in the network monitoring system. And then it will improve network visibility by ensuring that network functions smoothly by detecting malicious activities and displaying results on dashboard banner. Now you have a centralized monitoring system where everything from packet capture to user interface after data has been stored will be displayed on one particular dashboard managed by any particular network engineer. Now you have a modular architecture and an open source implementation, because this project will be sent or displayed on the GitHub repository. And the implications of this project, improve cyber security monitoring and enhancing network visibility and decision making. That is one stuff or one implication of the project after it has been run successfully. And you have support for scalable and modular architectures by enhancing flexibility and maintainability in cybersecurity infrastructure. This is a reference from Pressman 2000. Here you have for future work, you have future improvements that were made or proposed by the network security monitoring system. Here you would understand that machine learning based detection. Some of the future works include integration of machine learning techniques, because now you have a lot of AI attributed to a lot of systems. So you need to put in some machine learning where the network will be able to do things the way it should in an advanced system. You would have an automated incident response in such a way that if there is a network traffic, automatically the system is going to detect it. You have a cloud-based deployment where the system will be sent to cloud, like Google storage, you have on iCloud, you have a lot, Google Drive and any other cloud storage, so that data can manage and cloud. You have advanced threat intelligence integration, you have enhanced dashboard and reporting. You can see that Kibana not detect and displayed everything that was detected, or all malicious activities that were detected in the security system. And since as this system is built for small and medium-sized enterprises, this one for the future work, we're going to see how to improve so much so that it will support large-scale enterprise environments and mobile network monitoring support, because this one is just for PC. And then you have improved security and access control and commercialization and DevOps integration. Here you have my conclusion that this project successfully designed and implemented the integrated network security monitoring system using open source tools for Wireshark, Snort, Logstash, Elasticsearch, and Kibana, with the following achieved: successfully implemented the network security monitoring system using Wireshark, Snort, Logstash, Elasticsearch, and Kibana, achieving a 92% detection accuracy and a 1.8-second alert latency, demonstrating that the effectiveness of intrusion detection and centralized dashboard visualization was good and provided a scalable and non-effective cyber solution for small and medium-sized enterprises. Here you have my reference that I used. My references with their URLs that these texts can be found or located. Thank you very much for the presentation, and I'll be looking forward to pass this course with you. Very great. Now, giving in this part of the combined video a brief setup explanation of what happened. As earlier demonstrated or explained, Kingsley and Kingsley Elondo Nanje, and this will be the practical part of the project that was displayed in the presentation above. Now, in this project, I'll be using tools like Ubuntu, the Oracle VisualBox, Snort, Wireshark, Logstash, Elasticsearch, and Kibana. The very first thing I did was to download Oracle VisualBox. You can see here my downloads. You will find the VisualBox Oracle here that I downloaded. The next thing, I went further to download the Ubuntu 26.04. Now, after that, I successfully installed VisualBox and configured it as it should be. You have my virtual machine here running, and these are the properties. Running with hard disks, I allocated 2 processors for this, and with an optical hard disk and a video memory of 16 megabyte of RAM and everything like this. My audio may not be the best because my mic is like having a small issue. So, but I beg that the instructor understands and gives a listening ear to how I'm going to explain. So after installing the visual machine and installing Ubuntu in the visual machine, I have my Ubuntu OS here. I can then log in to my Ubuntu system with my password, and you would normally find whatsoever that is here. Now, what I will be talking about, this program will be running on a desktop application. And not only that, the system architecture, as explained in PowerPoint, from Wireshark, from packet capture, which deals with packet capture, Snort for intrusion detection, Logstash for log management, Elasticsearch for data storage and indexing, and also Kibana. I would To end it all, this project demonstrates that the network security management system successfully captures network traffic, detects threats using snots, processes alerts through Logstash, stores logs in Elasticsearch, and visualizes results in Kibana. The solution is effective because it integrates intrusion detection and CM, which is security information and event management functionalities into a unified open source architecture. The technical strength of this project is to enforce real-time monitoring, open source, and a cost-effective network, centralized log management, and a modular architecture with scalable designs suitable for small and medium-sized enterprises, demonstrating that the proposed system achieves its objectives of improving network visibility, supporting intrusion detection, and providing centralized security monitoring. The project achieved a detection accuracy of 92% with an average alert latency of 1.8 seconds, demonstrating its practical applicability for small and medium-sized enterprises. To end it all, this project demonstrates that the network security management system successfully captures network traffic, detects threats using snots, processes alerts through Logstash, stores logs in Elasticsearch, and visualizes results in Kibana. The solution is effective because it integrates intrusion detection and CM, which is security information and event management functionalities into a unified open source architecture. The technical strength of this project is to enforce real-time monitoring, open source, and a cost-effective network, centralized log management, and a modular architecture with scalable designs suitable for small and medium-sized enterprises, demonstrating that the proposed system achieves its objectives of improving network visibility, supporting intrusion detection, and providing centralized security monitoring. The project achieved a detection accuracy of 92% with an average alert latency of 1.8 seconds, demonstrating its practical applicability for small and medium-sized enterprises.